Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ifa binti Ahmad Kamisi and my student ID is 2024-276042.
Hi, my name is Muhammad Nazri and my ID number is 2024801632.
Assalamualaikum, my name is Muhammad Najuddin bin Umar RC and my ID number is 2024237982.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Zulaikha Yasmin binti Zaruni and my student ID is 2024444318.
In calculus, differentiation is the process of finding the derivative of a function. There are so many techniques that we use for differentiate to find the derivative of a function. The first one is power rule. Power rule is used to differentiate function with powers. To differentiate, we have to bring the power to the front and subtract 1 from the exponent. For constant rule, the constant must equal to 0 because constant does not change. And for the linear rule, b is constant, so it is equal to 0. And for ax is equal to a. Other than that, we have difference rule and sum rule. We will use this rule when the function involves addition and subtraction of two smaller functions. Another technique in differentiation is product rule. Product rule is used when the two functions is multiplied. The value of u and v need to differentiate to get the answer for v prime and u prime so that we can substitute and solve the product rule equation. Quotient rule is used when the two function is divided. For numerator, we assume as u and denominator, we assume as v. So we can differentiate to get the u prime and v prime and substitute it to the quotient rule equation. Chain rule technique is used when a function is inside another function. For example, we have a function 3x power 2 plus 1 exponent 5. 3x power 2 plus 1 is one function and 3x power 2 plus 1 exponent 5 is a one function. So how do we solve it? The exponent 5 we will bring to the front so that we get the differentiate is 5 times with 3x plus 2 plus 1 exponent 4. And for the function 3x power 2 plus 1 is the power 2 we have to times it with value 3 so that we get 6x, and for the value 1 it is must equal to 0 because it is constant. Trigonometric function is a technique that we have to memorize the basic of derivatives such as sin x equals to cos x so that we can differentiate easily. The derivative for exponential function is same as its function. Example, e exponent x is equal to e exponent x. Formula for logarithmic function is ln x equals to 1 over x. Example, we have a function ln 3x power 2 plus 1. So the differentiation will be 1 over 3x power 2 plus 1 times with 6x.
For question 2, we need to find dy dx or differentiation for the following function. Question 2a, 3x squared secant x plus 2 and 2b, y equals 4x plus 2 over cos x. For question 2a, we need to use product rule because the relationship between 3x squared and secant x plus 2 is multiply. The formula for product rule is uv prime plus vu prime. We got u equals 3x squared and u prime is 6x. V equals secant x plus 2 and V prime is secant x plus 2 tan x plus 2. So include all of that to the formula and differentiate that. We got the answer dy dx equals to 3x squared secant x plus 2 tan x plus 2 plus 6x secant x plus 2. Question 2b, y equals 4x plus 2 over cos x. For this question, we need to use quotient rule because the relationship between 4x plus 2 and cos x is divide, and the formula for quotient rule is vu prime minus uv prime over v square. U equals to 4x plus 2 and u prime is 4, v equals cos x and v prime is negative sin x. So include all of that to the formula and we got dy dx equals 4 cos x plus 4x plus 2 sin x over cos x square.
For question 3, we get that y ln 3x minus exponent power of 2x plus 1 minus tangent for y equal to 0. When we first get this question, we must know that y ln 3x has a relationship of multiply. So, in order to differentiate it, we must use product rule, which is uv prime plus vu prime. And so, for u, we got y, and for u prime, we got y prime. For v, we got ln 3x, and for v prime, we got 1 over x. And now, we just need to substitute the value of y prime, v prime into the formula, which is uv prime plus vu prime minus exponent 2x plus 1 minus tangent for y. Well, in order for us to differentiate exponent 2x plus 1, we must first rewrite the original question, which is exponent the power of 2x plus 1, and we multiply by the differentiation of the power, which is 2x plus 1. When we differentiate it, we got 2. And then we multiply the exponent power of 2x plus 1 multiplied by 2. And for negative tangent for y, we differentiate tangent and we got second square. And for y, in order to differentiate it, we must multiply by 4 and multiply by y prime, because we differentiate y equals to 0. And then for the equation, we got y over x plus y prime ln 3x minus 2 exponent power of 2x plus 1 minus 4y prime second squared for y equals to 0. And as for now, we have already differentiated, but we must first classify it into two different sides, which is the other side is y prime and the other side is all the others numbers. Okay, first we transfer the negative 2 exponent 2x plus 1 minus 4y prime second squared for y into the other side, and we got y prime ln 3x minus 4y prime second squared for y equals to 2 exponent 2x plus 1 minus y over x. And then we factorize y prime so that we can make y prime on the other side. Then when we factorize, and then we got the final answer, which is y prime equals to 2 exponent power of 2x plus 1 minus y over x over ln 3x minus 4 second squared for y.
Question 4. Use linear approximation to estimate the value of 4 cert 80.99 minus 2 over cert 80.99. Correct 3 decimal places. The formula we use in this question is first linear approximation, which is f bracket x naught plus delta x equals to f bracket x naught plus f prime bracket x naught delta x. And the second equation is delta x equals to x minus x naught. When we get this question, we have to know the value of x, which is 80.99. Next, we need to define the function. The first function is fx, which is already given in the question, but we need to change from the value into x. So we get fx equals to 4 set x minus 2 over set x. Fx equals to x power of 1 over 4 minus 2 over x power of half. Thus, fx equals to x power of 1 over 4 minus 2x power of negative half. The second function is f prime x. To find f prime x, we need to differentiate the fx. So, f prime x equals to 1 over 4 x power of negative 3 over 4 minus bracket negative 1 bracket x power of negative 3 over 2. F prime x equals to 1 over 4 x power of negative 3 over 4 plus 1 over x power of 3 over 2. Next, we need to calculate delta x. As we know, the delta x formula is delta x equals to x minus x naught. What is x naught? X naught is the closest number to the value of x, which is 80.99. And when we square root the number of x naught, we will get the integer number. So in this question, the x naught is 81, which is when we square root it, we get value 9. Next, we substitute the value of x and x naught into the delta x formula. So we get delta x equals to 80.99 minus 81, and the answer is negative 0.01. Where we get the value of x naught, delta x, and the function which is fx and f prime x, we can finally use linear approximation. First, we substitute the value of x naught, and delta x. Then we substitute the function fx and f prime x. So f bracket 80.99 equals to 25 over 9 minus 31 over 2916 times with negative 0.01. F bracket 80.99 equals to 25 over 9 minus 31 over 291,600. So, final answer is 2.778. Remember, the answer must be in 3 decimal places according to question's intent. And done!
So, in conclusion, we need to identify all of the techniques of differentiation and we must know how to use it correctly. For example, if the question asks for a rational function, we need to know in order to solve it, we must use quotient rule. Lastly, we need to be extra careful while solving the differentiation question because we might be made careless mistake and confusion might occur when using the formula.